This is the fourth video on Newton's laws and connected particles. So the Inuit tribe here from Greenland and Alaska in Canada, they pull a sled from rest. The sled and the luggage have a total mass of 800 kilograms. And they've actually given us a diagram here, but we're going to do our own diagram. And the force being used here is 100 newtons. And that's the tension in the rope. So we have my diagram. I'm always going to use a block like this. We have my tension in the rope, which is 100 newtons. We have my mass, which is 800 kilograms. So my force is equal to my mass times my acceleration. 100 is equal to 800A. So A has to be 1 over 8 in this case. ms to the minus 2. That's what we were asked to find. And the distance covered in the first 10 seconds. Distance in the first 10 seconds. When we have acceleration and we have that it started from rest, so u is equal to 0. S is equal to ut plus the half at squared. You know these equations off by heart at this point. So u being 0, we just have the distance is a half by an 8 by 10 squared, which is 100. So the distance covered is 100 over 16. 6 16s is 96. So that's 6 and 4 over 16. 6 1/4 meters covered in the first 10 seconds for this example. Nice easy questions. A bullet of mass 80 grams is traveling horizontally with velocity 100 meters a second. It stops when it has become embedded in the tree 50 centimeters. We're dealing in meters per second, so I'm going to straight away change that to 0.5 meters. Find the resistance of the wood of the tree, assuming that it is uniform. And then the second part, if the bullet had been a different mass. Right, so let's see what we have. We have a bullet going in this direction, and it's going to hit a tree. That's supposed to be a tree stump. So it's going to hit this tree, and we've got its velocity. So it's moving at 100 meters per second. It started, it's going to hit the tree, so it's going to come to rest. So the velocity is going to be 0 at some point. It's going to, does it say? Oh, it goes into the tree. It does. It goes into the tree up to here, 50 centimeters. It's going to come to rest. So we can say that S is equal to 0.5. Just writing down our variables will help us see into the question what we need to do. So we can definitely get acceleration here with these three variables using v squared is equal to u squared plus 2as. Should give us acceleration here. So it finishes, it comes to rest. So we have my 100 squared plus twice 0.5 times a. So a is just equal to 100 squared, the minus version of it, so minus 1, 1, 2, 3, 4, minus 10,000. ms to the minus 2 is acceleration. And then we're looking for the resistance of the wood of the tree. So what have we got now? We have the mass of the bullet. So we're going to be using my forces here. So we have the mass of the bullet in kilograms is 80 grams. So we want it in kilograms. Mass, let's just double check here. 100 grams, always just be sure, is 0.1, 0.10. So the mass is it's 80, so it's 0.08. Will give me the 80 there, if you can imagine that's the 80. So I have force is equal to ma, and now I have my m and I have my a. 0.08 by minus 10,000. So multiply by 8 and knock off 2 zeros. We're going to get F is equal to minus 800 newtons. So we have a negative resistance force in the opposite direction, which makes sense. Now the resistance, that's the resistance of the wood of the tree, is minus 800. Has to be. So what if the bullet's mass had been 100 grams? Okay, if its mass had been 100 grams, let's use this same equation here. If its mass had been 100, how much further into the tree would it have gone, or how far into the tree would it have gone if all the measurements remain the same? So we're looking for S. Okay, so what do we have? If the mass was 100, we're going to have this minus 800. The resistance of the tree is equal to the mass, 0.1 this time, 100 grams by acceleration. So the acceleration is going to change because of the mass of the bullet has changed. So acceleration in this case is going to be, just add a 0 there. That's minus 8,000 ms to the minus 2. So we have acceleration. So it was traveling at the same, all the other measurements remain the same. Okay, so it's traveling at the same speed. It was going at 100 meters per second. So we have A, we have U, we're looking for S, and it comes to rest. So we've enough variables here to use V squared is equal to U squared plus 2AS. It stops. It was traveling at 100. Twice minus 8,000 by S. So we're going to have 16,000 S is equal to 10,000. 16,000 S is equal to 10,000. So divide by my 16,000. You'll always know you're right in these questions when you're getting distance, that this has to be negative in here. Otherwise, we're going to have a negative distance, which doesn't work. So 10 over 16, 5 over 8. So it's going to travel 5 over 8 meters into the wood. 62.5 centimeters is the distance it's going to travel into the wood. So always with these questions, take your time, write down your variables and see where it takes you. Read the question carefully, and it shouldn't pose too much difficulty.